Frequently, when solving a problem in calculus, you'll arrive at a stage like this where you've got an expression that has to be simplified. And the purpose of simplifying an expression is to put it in a form in which you're able to see more clearly the behavior and properties of that function. And sometimes that's a necessary step in order to proceed with the next stage of analysis. So simplifying something like this requires two things. First, you have to know the algebraic techniques which will lead an expression like this to simplified form. And then second, you have to be able to perform those steps correctly. And on that latter score, you'll have to develop methods to make sure that you're doing the work carefully as a way of checking yourself as you go. And as for the former, that's the purpose of this tutorial, to lead you through the types of steps that will bring this to simplified form. The problem instructions give you an indication of how to proceed. You want to convert this to a fraction that is a single fraction, which will have no negative exponents. So if you'd like to give that a try on your own first, you can do so. Hit pause, work through the problem, and then come back when you're ready to continue. Okay, so I'm going to take you through two methods of simplifying this expression. The first one is a longer method. It makes all of the steps explicit, but they are steps which you can apply virtually always when you're attempting to simplify something. The second method is a bit more abbreviated. It's one that works particularly well for the types of problems you'll encounter in calculus, but it does require that you're able to do some of the steps in your head. So first thing, we know we don't want any negative exponents in the final answer. So let's take care of the negative exponent that appears here. We'll rewrite this first term so that it has no negative exponent. We've got x, which is going to stay in the numerator, multiplied by x minus 1, which now goes into the basement with a positive 1/2 as its exponent. And the second term comes down unchanged. There it is. So that's one of our guiding principles when simplifying an expression. If a negative exponent appears, rewrite it as a positive exponent by sending any term that's in the numerator down to the denominator. Okay, we've got a fraction here combined with some other terms, and that leads us to another one of our key guiding principles. Namely, if you've got a fraction that's being added or subtracted to other terms, you will just about always want to combine that fraction with the other terms to form a single fraction. So let's first rewrite this second term to make it clear that we can treat it as a fraction too. Now, as always, when adding fractions, you need a common denominator. When you have denominators with different factorizations, your common denominator is simply the product of the two. In this case, that means our common denominator, which I'll write on the next line, is just going to be x minus 1 to the 1/2 power. That denominator is already present in the first term, so there's no modification that has to happen to the first term. But in the second term, we're going to have to multiply top and bottom by x minus 1 to the 1/2 power. Now we've got two terms that have the same denominator. Bring down the numerators now. Here we've got just x. Here we've got a factor of 2 multiplied by x minus 1 to the 1/2 times x minus 1 to the 1/2. And anytime you have the same base being multiplied together, you simply add the exponents. So we're going to have x minus 1 to the power of 1, 1/2 plus 1/2, but there's no need to write the 1. Now before we go further, I have to note an important caution here. It's very common for people to look at an expression like this and say, oh, I've got an x minus 1 here, an x minus 1 here. I can cancel. That's going to simplify the problem tremendously. Well, you can't do that in this problem. In order to cancel a term from the denominator, that same term must appear in each of the terms being added or subtracted in the numerator. Yes, we've got an x minus 1 here, but we don't have an x minus 1 out in front, so there's no cancellation that can be done. But we can simplify the numerator, and that's another step that is almost always going to be occurring when you're simplifying expressions. Namely, once you've combined your fractions, you've got a numerator that will need to be simplified. We're going to distribute the positive 2 here to produce a plus 2x minus 2. And let's simplify. Let's rewrite that on the next line. So we've got x plus 2x, adding like terms now. That'll give you 3x and minus 2. There we are. And as you look at this term, you should see that there's no further simplification that can be done here. There's no way we can factor this term to produce an x minus 1 to cancel with the x minus 1 in the denominator. However, there is one final matter of formatting that's often done. Anytime you have an exponent of 1/2, typically you'll rewrite that term using the radical sign. So we'll write that then as square root of x minus 1. These mean equivalent things, it's just a matter of formatting. So to review the guiding principles which enable us to simplify this expression. First of all, anytime you have a negative exponent, you're going to rewrite it as a positive exponent. Second, anytime you have fractions being combined, you'll want to do so. That's going to involve a common denominator. And then finally, denominators you'll usually leave alone, but your numerators will have to be simplified. And the formatting note, if you've got an exponent of 1/2, you'll rewrite it using the square root sign. So that's the first method. And now I'll show you a second method of simplifying this problem. Okay, for the second method, observe that each of these two terms has a factor of x minus 1 in it. And that commonly occurs in calculus, that you'll have terms combined with common factors. So we're going to take this factor of x minus 1 to the negative 1/2 out of both expressions. We'll divide it out. We'll have x to the minus 1 to the minus 1/2. We're dividing that out of the entire expression. Dividing it out of the first term leaves us with just an x. Now over here, dividing it out of the second term, the 2 is going to remain unchanged. When you're dividing like terms with exponents, you subtract exponents. You take the exponent of 1/2. Let's write that down. Exponent of 1/2. Division involves subtraction of exponents, so we're subtracting the exponent of minus 1/2. All right. Combining those two, then, we have a power of 1. In other words, we're left with an expression like this. X minus 1 to the minus 1/2 times x plus 2 times x minus 1 to the 1 power. So that's the key thing with this type of problem, seeing that you can take out a common factor from both terms of the expression. And in this case, the division was accomplished by subtracting exponents. All right, now we have a term here in brackets which can be simplified. It's just like the one that appeared in the numerator of the previous problem. Likewise, we've got a term with a negative exponent, so we can rewrite that as a denominator. If you do those steps, you've got x plus 2 times x, or 3x, positive 2 times a negative 1, negative 2 to be subtracted. Then downstairs, x minus 1 to the 1/2 power. And as noted before, just as a matter of formatting, we'll rewrite that exponent of 1/2 as a square root, like so. So that's a faster way of simplifying an expression like this that takes advantage of the fact that both terms have a common factor, which again is something you'll see in calculus quite commonly. We removed the x minus 1 to the minus 1/2. That left only an x in the first term. The second term, we had to divide that term out. We accomplished that by subtracting exponents. And then that left us with a term here to be simplified and a term here with a negative exponent, which we brought down to the denominator. So that concludes this first tutorial. There are 2 problems similar to this one in your assignment. Give them a try and see how you do with them.